lesson objective is pretty simple. Okay, I want to try, I've shared with you already today's intention, we want to try something different, okay? An IBL lesson. What is an IBL lesson? Some of you have asked me, inquiry-based learning. It's always been used for science, okay, but over the years, certain schools in the US, they've tried to shift it to mathematics already. Okay, some schools have already tried adapting IBL to mathematics. We're trying to see whether can this work around. So it is just a lesson, okay? But we are trying to use an IBL student-centered approach to help you learn the sine rule today. Okay? Before we start the lesson, I will remind you again for the sake of my mentees. Okay, so I need to demonstrate to them about routines in class, the raise of hands. We try to minimize call out. So please try if you can. I know Arvin will raise the hand. Hey, Arvin a little bit. Okay? It will do you a lot of good. Okay, let's do a very quick recap. When we talk about trigo, okay? Let me see if my nightmare is true, Okay, let's recall trigo. Okay, when we talk about trigo, the first thing that came to your mind was Pythagoras theorem. What does the Pythagoras theorem state? What does Pythagoras theorem state? Loud public speaking voice, public speaking voice. The square of the hypo is equals to the square of the sum of the sides. Okay, can we listen to this response? Okay, can we just look at the words that she used? Okay, is it accurate? Can we improve on this answer? The square of the hypo is equal to the square of the sum. Is it the square of the sum or sum of the square? You must know, girls. Okay, I sidetrack a bit. That's not my lesson. Square of the sum refers to this. A plus b square. Sum of the squares is a plus b square. You must know the difference. Okay. So the Pythagoras theorem says that the square of the hypo is equal to the sum of squares of the other two sides. Pythagoras theorem is useful in finding the length of a right angle triangle. Am I correct? So after learning Pythagoras theorem, you introduce trigo ratios. Okay, what are trigo ratios? Anybody? Trigo ratios? See, all going to raise hand now. Yes, my dear. The sine. I always say it's a sin not to know. You must know your sine. What else is your sine? Cosine and everybody? Yeah. The sine, cosine, and tangent. The so-called torcaso. Am I correct? The big-footed auntie, right? But I already told you, we don't keep using the word torcaso because it's a Hokkien phrase, right? Use words like trigo ratio, trigonometric ratios. Okay, so it is your sine, your cosine, and your tangent, right? All these ratios basically allows you to find the angles and length of a right angle triangle. You have learned all this in Set 2. Am I correct? So today we're going to stretch a little bit further. I'm going to introduce another rule to you. Okay, an extension of trigonometry. We're going to do this extension of trigo to help you find length or angles of a triangle. Okay, about triangle, but what is the difference? You will find out. Okay, let's do a very quick recap very quickly. How many triangles do you know? How many different types of triangles do you know? Right angle triangles. Okay, can we practice the airing of armpit? Yes, my dear, air of armpit, don't raise your palm. Raise your hand. Yes, my dear. Isosceles triangle. We have isosceles triangle. And then somebody just now said right angle triangles. What else? What else? Yes, my dear. We have equilateral triangle. What else? Ever heard of acute triangles before? Acute triangles. I talked about it yesterday, right? Acute triangle. The word acute means what? The angle is less than 90. English word. Acute. I use that word, remember? Heading is acute. Am I correct? Acute triangle. So acute triangle, an example of an acute triangle would be equilateral triangle. All the angles are 60 degrees. So we call this an acute triangle. But let me ask you, must all acute triangles be equilateral? Okay, 60, right? Forms an equilateral triangle, right? Yeah? So there is an acute triangle and equilateral triangle. Okay, my question is, must all acute triangles be equilateral? No. Answer is no, right? So can you give me an example of three angles? Angle A, angle B, angle C, such that it is not equilateral, but yet it is acute. Go.
40, 60, 80.
Thank you very much. 40, 60, 80. Everybody get an idea? 40, 60, 80. All the angles are acute. At the same time, it is not equilateral. Okay. So other than acute triangle, so we have acute triangles also. We also have obtuse triangle. Yesterday when I went through trigo equations with you, I also talked about the word obtuse. The word obtuse tells you it's an angle between what to what? 90 to 180 degrees, correct? So over here, we look at a triangle that is obtuse. So over here, we can have this situation, example. Let's say I have something that looks like this. This is 110, this is 20, this will be 50. Okay, this is a very good example of an obtuse triangle, whereby one of the angles is more than 90 degrees. Are we okay with that? Okay, before I move on to the next segment, I just want to ask you, is it possible for a triangle to have two obtuse angles? Possible or not? Think before you speak. Possible? So no, not possible. Why not? Denise, why not? Because? Very good. Okay, can everybody hear that response? Okay, because obtuse angle is between 90 to 180 degrees already. So sum of angles of a triangle is already half is 180 degrees. It is not possible to have two obtuse because it will overshot 180 degrees. Okay. Okay. So I'll move on to the next segment. So far, all the stuff that you've been learning, your Pythagoras theorem, your trigo ratios. Am I correct to say that all these theorems that you have learned basically allow you to solve for triangles, but only one type of triangle? What type of triangle are you're capable of solving right now at this stage in your life? Right. Only right angle triangles. Am I correct? Only right angle triangles. But we know that in real life, okay, in real life, it is not everything is just right angle. What if it's not right angle? What do we do? Right? Today's lesson, we're going to go into that. Okay, but before we go into that, to learn about other rules of how to use trigonometry to solve for different type of triangles, just want to quickly ask you to find out, okay, what are the possible uses of trigonometry in real life. I learned trigo for what? Okay, if I ask you, why do you learn trigo? Why do you learn trigo, Abby? Because you learn trigo so that you can teach your daughter next time. Correct? Correct. Okay, that's not a good response. Sorry, video, I'll do that again. Why do you learn trigo? Because public speaking wise, because find the unknown in a triangle. Okay, so I guess when she grows up next time, her job, her real life will just go around find triangles and measure length. Okay, no, not true. Okay, tell you what. I'll pass now the worksheet for today. Don't turn to the next page until you are told to do so. Okay, don't turn to the next page until you are told to do so. Okay, if there are extras, the last person just hold on to it. Later, I'll come and collect. Show of hands. Everybody has this already? You have, raise your hand. Let me know. Okay, good. So what I want you to do now is this. You whip out your phone. Oh, you don't have yet? You whip out your phone. Everybody whip out your phone. Okay, or last time you have already tried it on the millions already. Okay, whip out your phone. I just want to check that every pair has an app of Orasma. If you don't have, you tell me now. Any one of the pair that doesn't have the Orasma app, or you never follow me, you raise your hand up. Anybody? Have or not? Don't have? Good. Okay, in that case, whip out your Orasma, right? So the people, who are the number ones? Raise your hand, who are the number ones? Okay, the number ones, you look at the first video, okay? Okay, before you play, I'll tell you when to start, okay? Look here first, everyone look here. Okay, put down your hands. The number one people look at the first video. The first video is more humorous, okay, but they talk a lot of nonsense now. But it's a good video, okay? The number two people, raise your hand, number two people. Okay, then put down your hands. The number two people, you look at the second video. The second video is more monotonous, there's nobody speaking, but it's more informative. Okay, so what I suggest is this, okay? The one people look at the one, the two look at the two. Then after that, we will have time for you to share with one another what you have learned from the videos, okay? What are we watching? We are watching how trigo is applied to real world context. Yes. Okay, at your own time, when you're ready, on the Wi-Fi or use your 3G, 4G, plug in your earphones and then watch the video. I will give you 5 minutes. Listen now girls, I will give you 5 minutes. Okay? By 9:03, we will stop the viewing of the video. Okay, please begin. Okay, you go on to your own earpiece so that you don't distract other people. Don't disturb others. You click on it. Okay, girls, remember, you click on the video to store it into your phone, so you don't have to be overing the app over the picture. Okay, you just press it once, it will be stored into your phone already. Okay, 1 more minute. I just want to prove a point. How many of you, your phone can load both videos? Raise your hand. Yay! Can you shout out what is the brand of your phone? iPhone! Okay, I proved to you another point, a more powerful one. Okay, put on your hands. Whose phone cannot load the first video everyone can load? Okay, the second video is more grainy. I admit. The trigger image is a little bit more grainy. How many of you, your phone cannot work for the second video? Okay, tell us loud and clear. What is the brand of your phone?
iPhone!
No!
It is iPhone.
Is it iPhone? iPhone. I know it's Samsung, right? Tablet. Okay, it is about the camera capturing. But this one has to do with the quality of the image that I choose and then the printing. Because once I print it in black and white, it's also not as sharp. Okay? If I print in color, like your medium ones, it will be better. This one, I'm very sure Samsung, iPhone, everything can work. So for Aura Smart, sidetrack a bit. For those who are interested to use your Aura Smart, you want to use it in your CCA, you want to use it for your council, the setting of telling everybody, vote for me for president, you can use Aura Smart, but your trigger image must be sharp. Okay, consider that. Very quickly, can I have a different one out of the pair, okay, or the triads? Doesn't matter. 1 out of 3 or 1 out of 2. Share with us what have you learned about the practical use of Trigo in the real world. Just one use. Yes, my dear. Okay, girls, one voice. Okay, we learn or listen to. Yes, Abi. To construct building, measure heights of building for construction, right? What else? Yes, Manu. Music. What else? Yes, Manu. Nuclear physics. Oh, from the first video, right? Yes, Denise. Sorry, again? Very good. Distance between the planets, yeah, the stars, the moon. I just want you to know that trigonometry can be used in the real world context. So it's not just about Abby, it's not just about measuring length of triangle, right? So when you grow older next time, remember Trigo actually have practical uses, one. Okay? Okay, what I need to do now is this. Like I mentioned just now, all the theorems that you have learned so far are just stuff that allows you to solve for parts of a triangle, the length of the angle of a right angle triangle. But what if it is not a right angle triangle? So today's lesson, right, through investigative approach, okay, I'm going to make you construct your own triangle, okay, but listen to my instructions carefully, okay? Everybody, I need to turn to the next page. Okay, turn to the next page, okay? So we are going to explore what is the sine rule. What is it? I don't know. Okay, let's try to find out what this is. I'll give you the instruction. The worksheet tells you to construct a triangle. Okay, so I don't want this situation to happen. Okay, the triangle that you are constructing must be different from the triangle that your neighbor is constructing. If you have a triad, 3 of you, make sure all the triangles are different, okay? So example, if one construct equilateral triangle, the other one can construct an isosceles triangle, the other one can construct a scalene triangle, right? Remember I talked about the word scalene triangle. What's a scalene triangle, everybody? Scalene triangle. Not scary triangle, scalene triangle. Nurul, what's a scalene triangle? Can you call? Not very sure. You have to call on somebody else to help you. Pick somebody to help you. Ask a friend. You can call a friend. Call your dad. Who can you call? Do I have someone who knows? A scalene triangle must have an obtuse angle. Is this true? Good try, okay? Good try, but no, not exactly what I want. Scalene triangle, okay, I will share with you, okay? Because some of you will be constructing a scalene triangle. A scalene triangle, listen, you write it down in your notes, the teacher write it down. A scalene triangle is a triangle where all 3 sides are of different length. If all 3 sides are of different length, all 3 angles will be different. I repeat. A scalene triangle is a triangle where all 3 sides of the triangle are different in length. Okay? Because all 3 sides are different in length, the interior angles, all 3 interior angles will be of different size. Okay? I give you an example. 3, 4, 5. Easy. Right angle triangle, but all 3 sides are different in size, all 3 lengths are different. Okay? So very quickly, okay, I need you to discuss with your partner, with your friend. In triads, then you have to discuss which one you want to draw. Okay, discuss first. 10 seconds, reach an agreement. 10 seconds, reach an agreement. I know, some of you, the smarter ones will all choose equilateral triangle, right? Easiest to do. Okay, girls, okay, watch, Now when you're constructing, right, I want you to pay attention now, okay? When you construct the triangle, I need you to draw it in that space as provided as accurately as you can. Okay, how accurately you draw a triangle will influence the outcome. Okay, so I'll give you 10 minutes. Can you draw the triangle, construct the triangle now? The vertices of a triangle I have shared with you in my videos on YouTube. You know, I've talked about this. All the vertices must be labeled using capital alphabets, capital letters. The length opposite the vertices must be a small alphabet. Okay? I need you to do what is instructed in the worksheet. Okay? So, construct a triangle. It can be A, B, C, doesn't matter. If this is big A, the length opposite it is little a. If this is point B, the length opposite it is little b. If this is big C, the length opposite is little c. Followed by this means the size of the angle of the triangle. When I say the smart ones will go and pick all the equilateral triangles, they will always have an easier time where everything is all the same. Boxes in point number 4. Clara is done. Once you have finished your boxes in point number 4, okay, I need to do one last step. Okay, don't turn over to the next page, but you just move down to point number 5. Okay, fill in the boxes in point number 5. Find out the value of A over sine angle A. Round off your answer to 2SF. Okay? So you will take equilateral, right? Arvin, okay, look here. Okay, I walked around one observation that I had. I kept mentioning the word equilateral triangle. Okay, the boxes that you have, right? You have your A over sine A. You have your B over sine B. And then you have a C over sine C. How many of you did equilateral triangle? Raise your hand. Okay, so let me just use equilateral first. Okay, what values do you have? Yes, what do you have? 9.2. So I assume all are 9.2, right? What do you have? Your equilateral triangle? 6.9, all 6.9. Okay, 6.9, 6.9. Anybody else who use equilateral triangle also? Do you know what you have?
8.5.
All 8.5. Okay, watch here now. Nah. They're all the same, right? But this is not a very strong proof for the sine rule because they happen to be equilateral triangle. Okay, I walked around, I saw girls using constructing scaling triangle. What you have is, what do you have, my dear? What do you have? 8 points. Some of you have 8.7. I saw 8.7, right? 8.7, 8.6, 8.7. Am I correct? 8.7, 8.6, 8.7. Something like this. Anybody else have something that is of this nature that is extremely close? What do you have? 8.0, 8.0, 8.1. Okay, 8.0, 8.0, 8.1. Okay. Theoretically, okay. Is there anyone who did not construct an equilateral triangle, and yet you have this relationship? Nuru is the only one, is it? Oh, you have a few, 3. Okay, can we just listen to the response first? Then I explain to you why this happened. Okay? Nadia, what values do you have? 10 and 10. What kind of triangle did you construct? Normal. Wow, new category. Normal triangle. Is it a scaling triangle?
Yeah.
Okay. So you have a 10, 10, 10. Who else? Nuru, what do you have? 8.1. All 8.1. What kind of triangles do you have? This is isosceles. This is a scaling triangle. What else? Yes. Right angle triangle. 10, 10, 10. 10, 10, 10. So this is a right angle triangle. Okay. I need everybody to look here, okay? I need to draw you what we are seeing on the board. Okay. Initially, I was hoping that everybody will have what Nuru might have or Nadia might have, right? You can construct scaling, right angle, isosceles, obtuse. I don't care what kind of triangle you construct. I was actually really hoping for exact values like this, 9.2. The blue ones are equilateral triangle, don't need to say that. Just measure one, you know it's all the same. Because the values are the same, right? But the red ones are, I was really hoping for the different type of triangle that produces the same result. Okay, the green ones, we have something that's very close, 8.7, 8.6, 8.7. Alicia's one is 8.0, 8.0, 8.1. Very close, but there will be some disparity in the accuracy. Okay, why does this happen? Okay, why does this happen? Okay, anybody can tell me why do you think that happened? Anybody? No? Alicia can measure. Okay, I can tell you why. Could be got parallax error. The way we measure using our ruler. If we look at this angle, if we look at the top, the line you construct may not be exactly a straight line because not everybody knows how to draw a straight line. Sometimes it may be a little bit bumped, a little bit crooked. The angle that you're measuring also may not be exact. Again, it could be parallax error in the way we measure it. Okay, so that might have happened that resulted in a value being not the same. Is that okay? So it should be, theoretically speaking, it should be the same value, exactly the same. Okay? Okay? So just make a very small correction if you can. Just help me. If it's 8.6, 8.7, 8. Just help me. You just change it to 8.7. Okay? If it's 8.0, 8.0, 8.1, we just put this 8.0. Okay? This is for the next page findings. I want you to try to draw conclusions up from there. Is that alright? Okay, now turn to the next page. Very quickly, I'll just give you 3 minutes. Just run through the questions. I'm just asking you a question just to ask you to just reflect on what you have just found out.
Wait, you say all sides equal then all angles will be equal.
Okay, let's run our responses here. Okay, I have attention 5, 4, 3, 2, 1. So we just run through the responses, okay? So what do you notice about the 3 values in the 3 expressions in our question 5? I wanted you to reach the conclusion that, Mr. I realized they are all the Same, they're all the same. Okay? So check the value of A over sine A with a classmate. Does it have the same value? Is it the same? No, different. Some of you have 8.0, some 8.7, 8.5, all different values. Check the value of all the three expressions with a classmate with a different triangle. What do you notice? What do you notice, girls? What do you notice? Nuru, what do you notice? The values are also the same, right? The values can be different, but the values of all three values of your classmate are all the same. All three values of yours are all the same, but it is different value. It could be different because of different in triangles, right? Point number 9. As you're finding in question 6 and question 8, depend on which triangle you or your classmate draw. Does it depend on the triangle? No. Yes? No? Yes or no? No. Okay, why do you say yes? Why do you say yes? Interpret for me. Why do you say yes?
Because you got the different.
Different? Okay, the triangles are different. But although you have different types of triangle, the conclusion we had was A over sine A is equal to B over sine B equals to C over sine C. So, am I correct? So, actually, it doesn't matter what kind of triangle we draw. The point that I was trying to drive across is you can construct right angle triangle, isosceles triangle, equilateral triangle, scaling triangles, doesn't matter. But at the end of the day, we should all reach this consensus that A over sine A equals to B over sine B equals to C over sine C. Values can be different, but all three of them, the ratios must be the same. Are we clear? Okay, so point number 10, what I've just led you to discover, okay, is the famous sine rule. Okay, this is the famous sine rule. Bear in mind now, this is not the sine equals to opposite over hypo. It's not the same. That one is trigo ratio. This is the sine rule. It's two different things. Don't get them mixed up. Okay, sine rule is this: A over sine angle A equals to B over sine B equals to C over sine C. Okay, the sine, what you learn in set 2, the sine equals to opposite over hypo, that is known as the trigo ratio. Two different things. Okay, over here we have this relationship. Okay, now to go through this process. After this, I'll give you time for you to copy it in your tablet now, right? I will use this to prove to Serene that this is true. What we did just now was via an experiment. So mistakes can happen due to human error. Okay, now I'm going to prove this mathematically. Okay, very simply look it up. This over here we have a triangle ABC, a scaling triangle, big A, big B, big C. Opposite is little A, opposite is little C, opposite is little B. Correct? I drop a straight line down from C. Watch, don't blink. I drop a vertical straight line from C to the base AB. So I let this point be T. Okay? T is the foot of the perpendicular. T is the foot of the perpendicular from C to AB. Okay? So here I just use the word is the foot of the perpendicular. You all must be familiar with terms like this. I let this green color length be H1. Okay? So the angle formed over here is 90 degrees. 90 degrees. I want you to take a look at triangle CAT. CAT. If I let my reference angle be A, okay, I want to form, you look at triangle CAT, okay, CAT. Sine, where should I write it? Sine A is equals to, somebody help me. Sine angle A is equals to, sine A is equals to what over what? Come on. H1 over, easy? Simple manipulation, H1 is equals to B sine angle A. Are we cool with that? Is it very difficult? Don't need to be a rocket scientist to know this, right? Okay, now I want you to focus at angle B. I use double stroke to let you know that the angles are different. Okay, look at sine angle B. Sine angle B is equals to, again we practice our trigo ratios. H1 over A. H1 over A. Again, if I just do a very simple manipulation, I have H1 equals to A sine angle B. Correct? A sine angle B. So this is H1, this is H1. What can we do? We can put them together, right? We know this can be equation 1, this is equation 2. I can lump them together. They are the same. So B sine angle A is equals to A sine angle B. Correct? Yes or no? Again now, look, don't blink, don't blink. You blink, the magic is gone. The sine A, I bring it down as a denominator, but this is the same as over 1 over 1. I bring this sine A down as a denominator. I bring this sine B down as a denominator. Don't I have this relationship? Yes or no? Yes? So can I convince you, Sarin, that this is always true mathematically? Okay? Can? Okay, so this is I've just proven you the part for A over sine A equals to B over sine B. So if I were to drop another line, watch here. Okay, is this clear with everybody? Clear? Okay, now what I want you to do is, okay, give you 1 minute, you copy down what you need to copy, then you will try to prove another set of equations. Now I want you to try this, okay, using similar approach. Watch now, I'm going to erase off this green color line. Watch. There's a reason why I name it H1. Watch that now. See point A, again I drop a vertical line now. Vertical line, okay? I call this line H2. So this is triangle, this triangle. Okay, I want you to try now. Our focus is on angle B and then focus on angle C. Okay? I want you to reach this relationship that sine angle B over sine B equals to C over sine angle C. Okay, on your own, 1 minute. Go. Okay, we must understand where all this stuff comes from. We have previously proved that your A over sine A equals to B over sine B, and then actually I've proven it for me on the board, and all of you have tried it on your own to prove that B over sine angle B is equal to C over sine angle C. So since this is the same, I can link them all up. So this was a sine rule that you proved it correctly. Are we cool with that? Yes or no? Before I go to the application part, Nadia asked me a question just now. Said, Mister, what if I write it this way? Does the relationship still hold? Is it the same? Is it the same? That is the next point that I wanted to lead you to, right? Is it the same, girls? Everybody, is it the same? Yes, it is the same. It is just a simple manipulation. At this step, look here. At this step, everybody look at the board. At this step that I boxed it up in red. Okay, what Ashley did was she brought the sine angle B down, sine angle C down. If Ashley brought the little c down and the little b down to the other side, we will have our sine angle B over B equals to sine angle C over little c. Everybody clear with that? So it is the same. Whether how we phrase it. But if you ask me, Patrick, which one do you remember? I remember the one in green because I was first taught the one in green. So I always remember the one in green. Sine angle A over little a sine B. Okay? Okay, so now we come to the last part of this and I'm done for the day already. Okay? I'm done for the day. Last part of this. Okay, everybody look at this triangle. I just want to show you a simple application of this sine rule. Okay? What have we done so far, girls? Okay? We did a very simple activity to let you realize that mathematics, whatever you learn, you may not use it in real life next time, but there are human beings, there are people who apply Trigonometry in a new context. You have learned to state that what is the sine rule, this is the sine rule. The last part I'm going to come to now is the application of the sine rule. Okay, everyone watch here, very simple application. I promise you, everyone knows this. Okay, watch. This triangle, PQR, is a scaling triangle. PQ is 10 cm, Angle Q is 110. Angle R is 20 degrees. I want you to find the length of PR. The length of PR. If I were to use your Sec 2's knowledge based on Pythagoras theorem, can you do it using Pythagoras theorem? Can or cannot? No. Why not? Because can I use trigonometry ratio? If I will do it in one step, it's not possible. Not possible, right? In one step. So we have to result in, we have to use the sine rule over in this version. Okay, when do we recognize how do you use sine rule? The key thing you must always remember, when I was growing up, I always remember this, opposites. Opposites. You see, I have a 20 degrees, right? Look at the opposite. I have a 10. Look at 110 degrees, look at the opposite. It's always the opposite. I have one unknown. When you have an equation whereby you have 3 knowns and 1 unknown, can you find the last unknown? Yes, you can. So over here, just a simple application of the sine rule. Be it you write 10 over sine 20, PR over sine 110. Be it you write it this way, or you want to write it the way that Nadia would have written it. Nadia might have written sine 20 degrees over 10 equals to sine 110 degrees over PR. Doesn't matter, we will end up with the same conclusion. So from here we use just a very simple manipulation. PR is equal to 10 sine 110 divided by sine 20. Punch your calculator, here we go, 3s then. Are we okay with it? Very simple application of your sine rule. Just a few questions only. Okay, I just want to see whether you understand what I'm talking about. We just try these few questions. Okay, exercise 6C. So 1A, B, C.
Please remain still wherever you are in the school.